Hello everyone. We will now begin our study of the inverse cosine function. We start off the same way as we did with the inverse sine function, that is, run horizontal line tests on the graph of the cosine function to determine within which interval the function has a one-to-one relationship. Therefore, it will have an inverse cosine function. Now, for the sine function, we had restricted the domain to negative pi over 2 and positive pi over 2. That won't work for the cosine function because if we draw horizontal lines within that interval, we see that the lines intersect the graph at more than one point. However, if we restrict the domain between 0 and pi, this segment of the graph, and run the horizontal line test, it will pass the test, and therefore we can conclude it can have an inverse cosine function within that interval. Therefore, for the cosine function, the inverse function is restricted in the domain 0 and pi, with 0 and pi being inclusive in that interval. Let's formally define the inverse cosine function, denoted by the notation cos with -1 as the superscript. It's the inverse of the restricted cosine function y equals cos of x within the x values of 0 and pi inclusive. Thus, in notation form, we express the inverse function as y equals inverse cos of x, which means cos of y equals x, where y is a value within the interval 0 and pi, and x is a value within the interval -1 and +1 inclusive. Again, recall that the input to an inverse cosine function would be the value of a ratio, and that value would be anywhere between -1 and +1. The output value would be the measure of an angle that corresponds to the ratio that was input into the cosine function, and the only output values that would be accepted would be values within the interval of 0 and pi inclusive. As far as graphing the inverse cosine function goes, we can apply the same procedure that we did for the inverse sine function. We can interchange the x and y coordinates of some different points of the cosine function within the restricted domain and plot those points on the coordinate system for the inverse cosine function, connect those points, and we obtain the graph of the inverse cosine function. Let's study the graph on the right hand side, which is that of the inverse cosine function. Along the x-axis, we see the scale between -1 and +1, which are ratio values, because the ratios, the range of the cosine function, become the domain values of the inverse cosine function. So we have the x-axis scaled from -1 to +1. For the y-axis, the domain of the cosine function becomes the range of the inverse function. Therefore, we see that the y-axis has been scaled from 0 to pi. Now, let's look at some of the points, because we are switching the x and y coordinates of the cosine function. What was 0 and 1 in the cosine function becomes 1, 0 in the inverse function. Then another point is pi over 2, 0. That should become 0, pi over 2, and that lands here. It's a y-intercept point. And then the third point is at pi, -1. That should become -1, pi, which is up here. So this is one way we can draw the graph of the inverse cosine function. How do we find the values of an inverse cosine function? First, we have to remind ourselves that we are looking for angle measures that correspond to the cosine of a certain given ratio. We write it out as let theta, which is the angle measure, equals the inverse cosine of a certain given ratio. And then we rewrite it as cos of theta equals x within the restricted domain of 0 and pi, and then we use the table of special angles between 0 and pi with their cosine ratios. Look up the table to first find the x value, the ratio value, and then look up in the row above for the corresponding angle measure. Let's work through an example now. It says find the exact value of inverse cos of negative 1/2. To solve this problem, we first have to remind ourselves that we are looking for an angle measure theta whose cosine ratio would be negative 1/2. We start with step 1 where we write it in equation form. Let theta equals inverse cos of x, and we will replace x with negative 1/2. In other words, we are looking for the angle measure whose cosine ratio is negative 1/2. And then in step 2, we again write it out as cos of theta. That means cos of which angle measure has a ratio of negative 1/2. After that, we will pull up the special angles table between the interval 0 and pi, look up the ratio negative 1/2, find its corresponding angle measure, and that's going to be the answer to this problem. So we'll do that. We'll complete the problem in the next slide. Here we are in step 3 where we can refer to a table of special angles with the corresponding cosine ratios provided to us. We will need to first look for the given ratio whose inverse function we are trying to find. In our case, that's negative 1/2. We are finding the inverse cosine of negative 1/2. So look for that ratio in the lower row of the table, and then the corresponding angle measure, which is 2 pi over 3. So we arrive at the answer saying that the angle within the interval 0, pi, where cosine is negative 1/2, is 2 pi over 3. And that's the answer to the question, find the inverse cosine of negative 1/2. Now, remember that the cosine function will have an inverse function only within a restricted domain between 0 and pi. That's why the angles shown here are only between this interval. And 0, pi over 2 and pi are quadrantal angles. However, the angles pi over 6, pi over 4 and pi over 3 are angles in the first quadrant. 2 pi over 3, 3 pi over 4 and 5 pi over 6 would be angles in the second quadrant. So for the cosine function, the angle measures that we find would either be angles in the first quadrant or in the second quadrant. Now, if the ratio is negative for cosine, then it cannot be a first quadrant angle, because in the first quadrant all trigonometric ratios are positive. In the second quadrant, cosine is negative, so the angle that we found is indeed an angle in the second quadrant. You can always verify your answer to make sure that you have picked the right angle measure for the ratio given to us.